Hello friends, on this video we are going to learn how to read the schematic diagrams or the diagram in the PDF. So we'll open this diagram. So it will be open in the Acrobat readers, and this diagram have total 57 pages here. The 57 pages are there, and first we'll see the power sequence. That means the how voltage passes from battery charging sections, then it goes to 3 volt and 5 volt sections, then it goes to the SIO, and how SIO communicate with the CPU, because this is the latest generations of laptop. So here is a no PCH, so the CPU and the PCH is a combined, so it's called the SOC. So the SIO directly communicate with the CPU. So we'll see all the signals step by steps, and I'll explain you how to read the schematic diagram, how to find the values, what are the test points, and all we'll see in this video. So let's start. So this is the first page. We'll go to the second page. The second page given here a little bit block diagrams of the power sequence. Like here is the input. This is a AC adapter inputs, and the voltage is 19.5, and here is the mention the page number. The page number is 45. The AC adapter input page number is 45, and this one is battery, and battery is also the page number 46. Okay, adapter is in 45, battery in 46, and this section is called the adapter input and battery charging section on the page number 47. Then this voltage goes to the next section, like this 19.5 volt is going to the different buck converter. There are different buck converter, like here you can see here. So firstly it goes to the 3 volt and 5 volt sections. 3 volt and 5 volt section is called always voltage. Here is a mention, plus 5VALW, plus 5 volt always, and plus 3 volt always. Okay, so meaning of this, and the chip number is here is SY8270C for the 5 volt, and SY8286B, that is for the 3 volt. So here the chips are used, and the informations of this 3 volt and 5 volt sections is given on the page number 48. And then here is a 1.2 voltage. This 1.2 voltage is going to the RAM sections. RAM require total level of 4 voltages, because in this laptop use a DDR4. So DDR4 require 4 voltages, that is a 1.2, 0.6, 3.3 and 2.5. And this information is on the page number 49. The next is 1 volt, that is going to the PCH. That is here is the PCH and CPU is a combined. So sometime we call the PCH, or sometimes it's called the CPU. Both are the same chip here. So this information is a page number 50. And then the CPU core section, that is generate CPU core voltage, is called a VCC core voltage. Okay, and that is a VCC GT and VCC SA. Total 3 voltages are generated by the CPU core, and this information is given on the page number 52 and 53. And finally for the graphics core, this is a graphics core chips, and this graphics core chips, or it's called the VGA core, that is given on the page number 56. And these are the graphics RAMs are here. So the graphics RAM information is on the page number 55, and the graphics RAM voltage is 1.35, and CPU core, VGA core is called the graphics core voltage, that is somewhere around 1 volt. So these are the supply, and then here is a 1.8 voltage. This also going to the CPU, and that is information on page number 51. The chip here is used is SY8032A, and last is 2.5 voltage, which is going to the RAM, and that information on page number 49, which is given. The chip number is SY8032A. Okay, so these are the block diagram of the laptops power sequence, how the power flows. And this board is a compiler motherboard. The compiler motherboard normally start from LA number. the motherboard number is LAH3323P. Okay, so we'll go first to the adapter input and battery charging sections. So here is the adapter input section, and this is adapter jack, and it's called the PJP1. Okay, it is called the PJP1. So this voltage is come across this jack, and then it travel from here via this coil. This coil is called the PL11 and PL12. This coil is basically used to remove any spike or jerk within a DC supply, and these are the Zener diodes are used. If any high voltage spike is come, then it's ground that extra voltage, so that is why it's used. So, and this output voltage is called plus 19V underscore V in. So we have to remember this. So the next point is going to connect here only. So I'll scroll down the page, and this is the battery connector. Here's the battery connector. The battery is called a PJPB1. Okay, and this point is called the plus point. This point is called the plus point, 1 number and 2 number. It's a 12.6 volt battery, and plus 12.6 V battery, and these are connection like SM bus. Then it's called temperatures, and battery detect signals are there. Okay, so we'll scroll the next page. So now, so this is our adapter input and battery charging sections. Okay, so this is our sections, and here is my input voltage. This is my input voltage where the 19 volts come across this MOSFET. This MOSFET is a location. This is called the location number. This is called the location. PQB11 is a location number. So this is the MOSFET number. It's called a AO. It's called a AO, not 0. AONS32306. Okay, and this MOSFET is an N channel MOSFET. Okay, so this MOSFET is what? N channel MOSFET, because the arrow, this arrow is inside. Arrow is inside, so that's called the N channel MOSFET. And this 5 number is a drain pin, and 1 2 3 is a source pin, 4 number is a gate pin. Okay, and so the voltage come across the drain and is passed to the source. Okay, so this one is the second MOSFET, PQB12, PQB11 and PQB12, both are the N channel MOSFET, and the both gate are connected to each other, and the gate is controlled by these chips. This chip's location is a PUB1. Okay, so this is a location number of the chip, and the chip number is a BQ24725E. Okay, so this is a chip number, is a 20 pin chips, and these are the name of the pin. Okay, so that is a 20 pin chip. This 21 is mentioned here, that is a pad. That pad means the center point, that always ground. Okay, so now what we have to check here? The first we have to check whether it is mentioned V in voltage or B plus voltage or DC in voltage or VCC voltage. So we have to first find where it's mentioned. So it's not a V in mention is not here, then B plus is also not mentioned here, DC in also not mentioned here. Then what is the mention here? Is the mention here this V in voltage is mentioned. See, you can see on a pin number 20. So this is a pin number 20, and this is 19V in. So here is a plus 19V underscore V in. So here also plus 19V underscore V in. So that means these both points are connected to each other. Then this point and this point, the both points are connected to each other. So the 19 volt is coming here across this diode and then passed through this diode. This diode location is a PD. The diode location is always on start from D. So P for PCB, D for D, PDB, and the number of this diode. and this pass via this register. This register value is the location. First, the register location is a PRB6, and it's a 10 ohms resistor. Is a mention is a 10, that means it's a 10 ohm resistor, and 1% is a tolerance. So the 19 voltage pass via this diode, pass via this resistor, can come across pin number 20 at the VCC or the VIN. Okay, so this is the first point you have to check. If the voltage is not coming here at the pin number 20, then the probability that this diode may be open or this resistor may be open. Okay, and if the voltage is coming here at the pin number 20, then the next thing you have to check, that is pin number 16. It's called a regulator, REGN. This is a regulator pin, and here you should get a 6 volt. This is a linear voltage come out when the voltage entered into pin number 20, then it's come out 6 volt from pin number 6. So you have to check here a linear voltage at pin number 16. Okay, and if this voltage is not come across pin number 16, then the possibility that the chip could be the faulty. Okay, so you have to check that. After that, this chip will detect the AC detect signal, AC detect. Okay, so here is the AC detect pin, pin number 6, and here the same plus 19 VIN, that means this connections plus V19 in. So plus V19 in here also, that means wherever the name is written, same name, suppose plus 19V underscore V written here, and here also, and here also, that means all 3 points are connected to each other, that means they are the single connections. Okay, so the 19 volt come across this resistor, and the value of this resistor is PRB17, and this resistor is ohms is 422 kilo ohms, and is a 1% tolerance, and this 19 volt come across this resistor, and here is a divider circuit, here is a one more resistor, and the value of that resistor is a 66.5 kilo ohms, and the next point is connected to the ground. So this symbol is a ground, so this point is connected to the ground. Okay, so here is something around 2 point something 4 or 5 voltage come across this point, and this voltage is going to the pin number 6, and this signal is called the AC detect. AC detect. What do you mean by AC detect? AC detect means when the voltage come across here, that means this chip will come to know that the adapter voltage is present or the adapter voltage is appeared. If the voltage is here a 0 volt, then this chip will come to know that the adapter voltage is absent. So it's like that. So this is the pin number 6, AC detect pin, and then if this voltage come across this pin, then what this chip will do is he drive this signal pin number 4, and it's make it 0 volt here. Sorry, not make it 0, it's make it 19 volt. It's an N channel MOSFET. So drive this signal at pin number 4, and somewhere around 19 volt come across here, and drive this both the MOSFET. Is drive the both the MOSFET. So this signal is drive from here, and is drive this both the MOSFET here and then here, and when it's drive this 19 volt across this MOSFET, then the 19 voltage which is stand here, which will pass this two MOSFET, this first MOSFET, then the second MOSFET, and come across this resistor. Here is a current sensing resistor. So this is a current sensing resistor, and we should get here a 19 volt. Okay, and the value of this resistor is 0.01 ohm. The value of this resistor is very minute, it's below the 1 ohm. So this resistor is called a current sensing resistor. Why it's called the current sensing resistor? Because when the voltage pass through this resistor, then some minute voltage drops generate, and that voltage drops measured by these chips from here, ACN and ACP, pin number 1 and pin number 2, and calculate the current, how much the current is passing from this circuit. So that is why it's called the current sensing resistor. And then this voltage goes output to the this point. So this is a output point. Okay, and this circuit is called the battery charging section. Here is a battery. Battery voltage is 12.6 voltage is connected to the battery, and when there is adapter is absent, when we remove that adapter, at that time here also the N channel MOSFET use, and this MOSFET is basically for the discharge purpose. Discharge purpose means when the adapter voltage is absent, at that time the battery voltage will travel from via this point, then this point, and pass this MOSFET and come across the same point, which is here. Okay, so in this way this circuit work. So this section is called the battery charging section, and when the adapter voltage is there, then of course there is one signal is generated, that is important signal. So you have to check that signal, and that signal is called the AC. Okay, here pin number 5. Here you will get a 3 volt. And this voltage is going to the SIO. Okay, so this is the output signal. So this is the input signal, and this one is the output signal, and this one is a power, and this is a linear voltage. So all the signal you have to check, and this is the battery drive signal when the battery voltage to be drive, and these are the charging MOSFET. Here's a dual MOSFET is there in single packet. There are 2 MOSFET fitted in this package, so it's called a dual MOSFET. It's basically used to charge the battery. So friend, in this way the first section is work. It's called the battery charging section, and this voltage goes out, this section goes out, it's called plus 19 VB. Okay, so we'll go to the next sections and where this voltage goes. So here is my second section, 3 volt and 5 volt section. Now you will say, oh, how you come to know that this is a 3 volt and 5 volt section? Then there are so many clues are there. So one clue is when you go down at the corner of this page, is mentioned the Compal Electronics Incorporated, and here is a mention 3V always and 5 volt always is a mention this side. 3 volt always and 5 volt always is mentioned here. So from this line you can come to know that this is a 3 volt and 5 volt section, and this one is a model number of the laptop. Okay, so this 3 volt and 5 volt section is a single chip buck converter. That means in older models there are a single chip is there, and 2 MOSFETs outside. So that means 2 MOSFET for the 5 volt and 2 MOSFET for the 3 volt. So there are 4 MOSFETs and 1 chips. But now the latest schematics or the latest diagrams, they use a single chip. That means there will be no MOSFET. The MOSFET also included into the chips. So you won't find any MOSFET outside. So the MOSFET is also included in the chips, and only the coil and the capacitor you will find outside. Okay, so first we'll see how the 3 volt section works. So this is a 3 volt chips, and the location of the chip is PU301, and the chip number is SY8286BRA3. So these are 20 pen chips, and pin number 2, 3, 4, 5, 6. So this is the input supply. So here is going a 19 voltage coming out from that current sensing resistor, pass via this coil and goes inside to the chips. Pin number, these are the inputs pin, and then these chips have 2 enable. These chips have the 2 enable. Here is the first enable is called the LDO enable. Okay, so once the chips get 3 volt, above the 3 volt, it should be the above the 3 volt, then this chip will drive one linear voltage, and that is called, here is a LDO. LDO means a low drop output. Okay, so pin number 16 and 17 generate the linear voltage, and this voltage is called plus 3 VLP. So you'll get a 3 volt. Okay, and this 3 volt is going to the SIO. This 3 volt is going to the SIO, and when these chips get the another enable signal, that is a pin on the pin number 12, at that time this buck converter started functioning, and the 18 volt 19 voltage started switching, and then here is a 3 volt always which is generate after the power button press. So this voltage will generate after a power button press, and this voltage is generate before power button press, and this voltage is going to the SIO, and this voltage is going to the so many section, like is going to the RAM, is going to the BIOS, is going to the CPU, it's going to the LCD, it's going to the Wi-Fi, then network, then audio, then lead switch, then SSD, so many chips. It's going to 3 volt is going to the so many, like cameras and all. Okay, and below that there is a one more section is called that's called 5 volt section here. So this section is called a 5 volt section. Same thing, 19 voltage coming from adapter input and battery charging section, and then is entered to the pin number 1, and then once you get the enable, then it generate this 5 volt, and after a power button press, then on the pin number 6 it's get an enable signal, and then this chip will generate 5 volt here, and this 5 volt is going to the fan, then VRM chips, and then is a USB. If hard disk is there, then for hard disk, and then the audio amplifier. So this 5 volt is used for all those chips or all those circuitry. So friend, this is called the 3 volt and 5 volt sections. I explain you. I hope you understand this concept. Now we'll see where this 3 voltages passes. For that we have to go to the SIO, and we'll see which are the pins we have to check on the SIO. So we'll go to the SIO. The SIO is normally on the upper sides, because so this is, we are now on the page number 46. So we'll go up and we'll see where is SIO. So we have to scroll all this and we'll find yeah. So here is SIO. Here is SIO. So here is a mention. Here is a mention. SIO is a EC. SIO is a one more. There is a SIO 2-3 names are there. SIO is called EC. EC means embedded controller. Sometimes it's called KBC also. That is a keyboard controller. And the name of this number of this SIO is KB9022. It's made by ENE chips, ENE manufacturers. Okay. So 9022. And first we'll see. This is a SIO is a total 128 leg chips, and first is require a power. So we'll zoom. So these are the supply pin number 9, 22, 33, 96. Okay. So that 3 volt with the linear voltage which is generated, which is come across this point, and this 3 volt is coming via this resistor and entering into all the chips. So any of these chips from 9 to 96, you should get a 3 volt. So you have to check here a 3 volt. Location of the chip is UK1. Okay, so you'll get a 3 volt here, and after receive the 3 volt here on the SIO, then SIO need another signal that is called the EC reset. So this one is the EC reset, pin number 37, and you should get a 3 volt there. It's called the embedded controller reset, or it's called the EC reset. Okay, so we have to check that. And after that the next thing is a lead switch or the lead sensor. So we'll check where is the lead switch or the lead sensor is. LID is mentioned. LID, you can go from like this also, you can go here and just type LID. Yeah, so see, LID is mentioned. LID here, pin number 115, and here we should get a 3 volt. How much volt? A 3 volt as pin number 115. Okay, so this here is the number which is mentioned. These are the pin number of the SIO, and if the arrow is outside, if the arrow is like this, then that's the output signal. In arrow is like this inside, that means is the input signal, and if the arrow is on the both side, that means the bidirectional signal, and if it is like this, that means is a power. Okay, so this is a input signal of the LID, and you should get a 3 volt there. There is a lead switch or the lead sensor, which is a magnetic sensor. The magnet is there on the LCD screen, and when we close the shutter or when we close the LCD, at that time this sensor is activated and make it this 3 volt into 0 volt. So the motherboard will come to know that the door is closed. So it's like that. But in some time, what has happened, that magnetic sensor or the magnetic switch is short and there will be the 0 volt. So because of that, the SIO won't turn on the laptop. So you have to check the signal. It should be a 3 volt. Okay, so the lead switch. After the lead switch, then you have to go to the on off switch or the power button. Here is the on off button on the pin number 114, and this is going to the page number 40, and here you will get a 3 volt. When you press the power button, it's going to 0 and come back to 3. That means the pulse will be generated at pin number 114. That is a on off switch or the power button. So now as soon as you press the power button, at that time the SIO immediately generate this EC on signal. Here is the EC on signal, and before power on, this EC on signal is a 0 volt at pin number 112, and as soon as we press the power button, at that time here that EC on signal will become a 3 volt. So you have to check that, and if it doesn't work, it can't convert a 0 volt into 3 volt. In that case, at that time your SIO may be faulty or the SIO is bad. So you have to check that. Okay, so you have to check the signal, that is a 3 volt is here. 3 volt is here. Okay, and then the 3 volt and 5 volt buck converter will start functioning, giving the power, and then SI will generate the next rest of the signal, that is called the RST, that become a 3 volt is going to the pin number 9, page number 9 to the CPU, and that is a 3 volt. Then it generate the DPWR. Okay, that is also going to the page number 9, the 3 volt. Okay, and then the PM power button, there will be the PM power button. So we will find where is this PM power button. We'll see here. Yeah, here this is a PM power button. Okay, so here is a PM power button, and this information is going to the CPU, and here 303 pulse will be generated. You should get a 303 pulse at pin number 122. Okay, and this information is going to the page number 9. Okay, this PBTN, PM power button or DNB power on, or either of one of the name will be there for the signal. And after that SIO should respond, and SIO send PM SLP S3 and PM SLP S4 signal. This signal coming from the CPU side. So here is the signal SLP S4, it's going to the pin number 123. Then PMSLP S3 signal is going to the pin number 6, and here's the SLP 5 also there. There are 3 signal, SLP S3, SLP S4, SLP S5. There are the different power states. Basically SLP S5 is used to turn on the always voltage, that is a 3 volt and 5 volt. SLP S4 signal is basically used to turn on the RAM supply, and SLP S3 signal is basically used to turn on the CPU core voltage. That means the ACPI 0 state. It's called a ACPI 0 state. So in this way, when the signal this 0 volt become into 3 volt, that means the CPU given the confirmation to the SIO to turn on the rest of the supply. Okay, so after that SIO started turning on the different buck converter. So we'll see where are the signal. So here these are the signal, and this first signal SIO generate, that is called the system on. So this is the signal, first signal, system on. This information going to page number 86 and 12, and this signal will turn on the RAM supply. The RAM is DDR4, so 1.2 will be generated after generating this signal. Then the next signal, that is called the main on. Okay, so we'll generate the next signal, and then after that generate the SUSP signal, 1.05 voltage and all, and then finally after this signal SI will generate VR on signal. Here is a VR on signal, pin number 85. Pin number 85 is going to the page number 88. Okay, so I think some mistake is there. 88 page number is not there. So this is a VR on signal, basically to turn on CPU core voltage. We generate the CPU core, and this signal has become a 3 volt after pressing the power button. So friend, in this way all the voltages are generated, and when the all voltage are stable, at that time this SIO get this input signal. This is called the VRM power good, input signal to the VRM at pin number 21, and after that this SIO will generate a final signal, that is called the system power OK. So this is called the system power OK, coming from pin number 76 and is going to the CPU. It's called the system power OK. So now what do you mean by system power OK? System power OK means when the all voltage are stable, like a 3.3, 5, 1.2, 1 voltage, 0.6 voltage, 1.05 voltage, 1.8 voltage, all the voltages, CPU core voltage, when the all voltage are stable, at that time SIO will generate this signal, and this signal is going to the CPU informing that the all voltages are stable. Okay, so in this way you have to check all the signal. So here you can see the most of the signal we are check here on the SIO only, and from that we can come to know where is the problem. Okay, so for the Dell laptop you have to simply follow only of this signal. So I hope you understand this this video and how to read the schematic diagrams of the laptops. Okay, thank you very much.